Good morning, ladies and gentlemen. I'm Milan Šimoník from Cogen Czech. Welcome to the workshop, which is co-organized by Cogen Europe together with Research Center Czech as part of the PACE project. Before we jump into the content, let me mention a few housekeeping rules. Today's webinar is being recorded and it will be shared together with the presentation on PACE and Cogen websites. You also invited to comment and ask questions. As usual, you can use either chat or raise your hands. Time for questions will be available after each presentation, and then again after the first and second block. Please keep your microphones off when you are not speaking. And now I'd like to ask Danesh Burket, R&D Director in Energy section of Research Center Czech, to kick off our webinar with his introductory remarks. Danesh.
Thank you, Milan. Good morning, ladies and gentlemen. It's a really great pleasure for me to welcome you on behalf of Research Center Czech at the seminar dealing with fuel cell micro-Cogeneration technologies in the Czech Republic. Let me briefly introduce Research Center Czech as the co-organizer, together with Cogen Europe, of this seminar. Research Center Czech was founded in 2002 as R&D organization focusing on development of technologies and technical support for power generation industry. We focus on research in the areas of materials, structure and system diagnostics, nuclear fuel cycle, and sustainable power technologies such as energy storage and hydrogen. Research Center Czech is a member of many international organizations, for instance, the European Energy Research Alliance, where our representative is a member of the executive committee. As I have mentioned, we are also active in the field of hydrogen technologies and their applications in the energy and transportation sector. Within the energy sector, we are investigating, for example, connection of hydrogen technologies to nuclear power plants, fossil plants, and renewable energy sources. In the transportation sectors, we are involved in a project of construction of hydrogen-based truck prototype or in the deployment of hydrogen filling stations together with our colleagues from UJV Czech. My colleague Lca will present our activities in the micro-Cogeneration units on a basis of fuel cells later today. I wish success to your seminar, and I'm looking forward to your interesting presentations. Thank you very much. And I am giving floor back to Milan or...
Okay, thank you, Dan, and you will be followed by Antonio Aquilo-Rulan, who is the project officer in the fuel cells and hydrogen joint undertaking.
Thank you. I hope you can hear me well.
Yes.
Good. So thank you so much. Thank you so much for the invitation, in particular to Mr. Danesh Burket and Cogen for organizing the event. My name is Antonio Aguiló, and I work as a project officer at the fuel cells and hydrogen joint undertaking, where I'm responsible here to follow all our activities looking at the production of heat and power with fuel cells. But who are we? What does our organization do? Basically, we are a public together the public and the private sector. The public sector is represented by the European Commission, and the private sector by the research and industry group in the field of hydrogen and fuel cells. Now, since 2009, 8 more or less, when we started in our first stage, We have supported around 285 projects for a value of 1 billion euros, 1,000 million euros. But of course, the public-private nature of our organization means that we have managed to leverage a similar amount from the private sector. So we have managed to leverage additional investments of 1,000 million euros to support projects in the field of fuel cells and hydrogen, research, but also demonstration projects with the aim of bringing to maturity fuel cells and hydrogen technologies. Is to say that the momentum for hydrogen is currently impressive. I mean, I'm sure you have picked on this. There was the hydrogen strategy published by the European Commission in summer 2020, and there are very, very challenging targets in the field of hydrogen. One of them, just to remark, by 2030, there are 10 million tons of clean hydrogen. That's important to mention. We're talking about clean hydrogen targets here. By 2030, around 10 million tons should be produced in Europe through 40 gigawatts of electrolyzer capacity. Now, the strategy focuses on the hard-to-abate sectors. It's mentioned heavy duty, it's mentioned industry. But it is also fair to say, and whilst the policy direction and while it's still uncertain in which manner this will happen, we can expect also the decarbonization of our gas grid through the injection, for instance, of hydrogen on the gas grid, but we can also expect dedicated hydrogen grids. Now, within that in mind, of course, the links to the building sector on one hand, but the links of both in the residential but in the commercial sites are obvious. And fuel cells appear, if you want, as the only technology that, if we think now about the smaller scale, about the domestic scale, as the only technology that can take advantage of this green hydrogen, produce renewable heat and power, and do that without impact in the local air emissions. Why is that? Well, they are electrochemical conversion devices. There is no combustion associated to it. So when running on pure hydrogen, you have hydrogen as an input, you have oxygen, and then the outputs are heat, power, and water. So that position fuel cells, and as I said, especially at the domestic scale, as a very unique proposition for clean heat and power using renewable hydrogen in this sense. I think since we started in 2008, we have been supporting this field. We have done it for a number of reasons. We have done it because, of course, in line with the energy efficiency policies back in time, fuel cells appear, or even if used when running on natural gas, as an efficient technology. It's also about fuel flexibility, as I mentioned. They are forward compatible with hydrogen. They produce clean heat and power, and also they produce electricity close to the point of consumption, which that certainly comes in support of the overall electricity network, reducing the demand, if you want, on the transmission network. How have we done it? Since we started, around 280 million euros of total support has been provided for the stationary fuel cell sector for heat and power production with fuel cells, around 84 projects. If we think about the domestic applications, that has consisted on 17 projects supporting since we started, with a total funding of 98 million euros. A total project cost of 244 million euros. Again, that shows you the involvement of the private sector. And the technology is a reality. In the last year, we have supported a number of large-scale demonstration projects. We have a number of European heating suppliers already offering this technology. You will have some presentations later on some of them. But it's very interesting as well to see that we have also managed to support a number of small and medium enterprises all the way from the beginning, stages where they were developing the components of the fuel cell, up to the point in time where we are now, where they are now deploying fuel cells in the field. If maybe to mention that the last main projects that we have supported on this field, looking at the deployment, one was the Enfield project that managed to install 1,000 units across different countries in Europe. And we have now an ongoing project called the PACE project, which will be presented later on, which is targeting the installation of close to 3,000 units as well across Europe. But there is more to that. Since we started the first field trial back in I think it was 2016, we demonstrated the technology. It was installed in real installations, end users got experience as well as by the manufacturers, and that triggered a number of support schemes across different countries in Europe. most notably the KfW 433 scheme in Germany, which altogether has seen now the support of in excess of 15,000 units in Germany. So it's fair to say that the experience in Europe on this sector, in this market, is of around 18,000 micro-CHP installation with fuel cells. There are other countries following. We have very good conditions in Belgium. Other countries follow up like Italy, UK, France, and trying also, thanks to the European support, together with national schemes, to increase the deployment of this technology across Europe. We have monitored the systems. We do have actually a system in which we monitor everything that comes out of our projects in terms of performance, in terms of the operational parameters. And this is, of course, the case with the field trials that we have supported on this sector for domestic installation of fuel cells for heat and power. And we have seasonal values of performance, and I can summarize some of them here. We have seen how in excess of 98% system availability has been achieved, showing that systems are ready and up to the standards of what is expected for real installations. Seasonal power efficiencies of up to 60%, which is quite remarkable, talking about here electrical efficiencies. Total system efficiencies of up to 95%. We're talking about running on natural gas between 30 and 50% CO2 savings relative to the conventional technologies. Once we have the conditions to run on pure hydrogen, as said before, we will be talking here about carbon neutral technology. And it's very important as well, because as I mentioned before, the hydrogen strategy is not only about climate transition, it's not only about supporting the carbon neutral targets of Europe, it's also about reinforcing European economy, strengthening our economy. And I think thanks to the projects that we have been supported, we have contributed to create a very strong European supply chain in this sector. And as I've mentioned before, we have on one end established consolidated heating equipment suppliers offering these technologies, as well as a number of SMEs that are now leading as well worldwide in this market. So we intend to continue supporting this sector in the next multi-financial framework. We are now entering into a new era for us. We are going to continue our public-private partnership. We will be called from now on was the Clean Hydrogen Partnership. So we will continue supporting activities and projects in the fuel cell and hydrogen sector, including the micro-CHP applications. It's true that it's unlikely that we will be able to fund flagship projects like the PACE project that will be presented later on. But as the technology is mature, I think what is necessary now is that national schemes come into place that are able at least to market activate the demand for these systems, so that then with the volumes, the costs can decrease. And then at some point in time, we hope that there will be no need for any additional support. So with this, I will end my speech, my contribution to this event. I really hope that this event will help us, everyone, to understand a bit more about the technology, to get confidence that this is a technology that is there, that is available, and that it can deliver already today. And as I will not be able to stay for the whole event, I'm happy to take questions now or in another means. You can contact me through Cogen or directly at any time, and we will be happy to share more information with you. Finally, if you go to our website, you will find a report that the Joint Research Center of the European Commission has drafted and published, looking at the outcomes of our projects on the stationary fuel cell sector. So there you will be able to find more details on our field trials and of our projects as well. So thank you very much again for the invitation today.
Thank you, Antonio. We don't have any questions yet, so we'll see later. And now I'll give floor to Hans Korteweg, Managing Director of Cogen Europe, who will present the PACE project itself. Hans, the floor is yours.
Good morning. Can everyone see my slides now?
Yes.
Perfect. So good morning. I'm very pleased to be here representing Cogen Europe as a coordinator of the PACE project. Just to introduce myself, I'm Hans Korteweg. I'm the Managing Director at Cogen Europe, and I'm going to take this opportunity to introduce you to the PACE project. You will hear more detailed information about the various different technologies that are applicable to fuel cell micro-CHP, in particular linked to this project. But to set the scene, I took one of our Cogen Europe slides to really paint a picture today. And I want to begin with this key message. Buildings are hard to carbonize. Heating and cooling in buildings up to, well, 40% of energy consumption are, well, they're responsible for energy consumption. Their buildings are 36 responsible for greenhouse gas emissions. Of those, 75% are based on fossil fuels. Today, almost 80% of the energy used is linked to heating and hot water, actually. And believe it or not, 85 to 95% of existing building stock will still be in use standing in 2050. And deep renovation of buildings stands around 0.02% a year, so not very quickly. And there is, of course, a lot of discussion about the role of electrification and heating, but looking at sectoral studies, even studies by the European Commission, up to 45% of heat could be electrified. That means there is a significant role for renewable decarbonized gases, including hydrogen, that will play a key role in helping to decarbonize buildings. Now, to pivot to the PACE project and what and why fuel cell micro-cogeneration. It's a highly efficient technology for home energy systems where you simultaneously produce heat and electricity. It's one of the most efficient forms of cogeneration, using a fuel cell to simultaneously produce heat and electricity. And so you can have system efficiency up to 95% and electrical efficiency up to 60%, depending on the technology you use. In terms of reducing CO2 emissions, today, fuel cell micro CHP runs on natural gas and already can help reduce CO2 emissions between 30 and 50%. Also, because it's a decentralized nature of the technology, it's responsible for saving primary energy, which is key, especially in relation to the EU's goal of reducing or increasing energy efficiency and primary energy savings. The technology operates with renewable and conventional gases. You can say that it's future-proof. Today it runs on natural gas. With a few changes, it can run on pure hydrogen. They produce and deliver energy on site, at homes, at businesses, and they cover a higher demand of electricity. There's another point that's not included here, but local air quality is also an important point. One of the benefits of this technology, fuel cell use, is that there is no combustion, so you virtually eliminate NOx and SOx from a local air quality perspective. So continuing on the benefits of fuel cell micro CHP, it's about empowering consumers. It's about giving them control of their heat and electrical needs. I must admit that I am a user of a fuel cell micro CHP myself. Put my money where my mouth is. I was very interested in the technology. I invested in it, and I've been running the fuel cell micro CHP in my own home for the last 2 years. So I'm happy to talk about that perhaps in the panel discussion. Of course, it supports the European energy transition in the sense that it helps reach energy efficiency goals, primary energy saving, but also from an environmental perspective in terms of reducing CO2 emissions and a local air quality perspective as well. It provides greater flexibility for the energy system. It can meet, for instance, in the wintertime, the electricity that's produced from the fuel cell micro CHP can help offset some of the electrical demands from heat pumps and other systems that are required to help keep homes warm in the wintertime. And of course, the technology is highly innovative, so it provides further innovation and provides high-value jobs. You've heard a few of these names already. There are a number of different projects over the past, say, 10 to 15 years that have been helping to promote and bring to market fuel cell micro CHP. You have Calux in Germany, followed by the KfW in Germany, the KfW 433. From an European perspective, through FP7 and Horizon 2020 through the fuel cell hydrogen joint undertaking. We have the Enfield project that was basically a field trial that had over 1,000 systems installed over 11 different European countries. That was succeeded by the PACE project, which began in 2016 and will in fact end in mid next year. The purpose of this project is really to bring to mass market the technology. So by helping reducing the price, increasing production, and bringing it to mass market. Focusing on things such as reducing costs, improving competitiveness, improving the performance of the products. So 2 different generations are actually involved in the PACE project. Establishing fuel cell micro CHP as a standard technology in homes and small businesses. Of course, raising awareness of the technology and its benefits, and of course, demonstrating the product readiness as a key component in delivering towards EU energy and environmental goals. So here is a quick project overview. The call year was in 2016. It is a large-scale demonstration of fuel cell micro CHP. The project will run its course and end at the end of June 2022. To date, around 78% of the project has been completed. By the end of this year, the project will have sold and installed all of the units earmarked. It has a total project budget of around 90 million euros. Of that, a third comes from public money, so from the FCHJU, and then other financial contributions come from the OEMs and manufacturers themselves. And the partners include BDR Termea or Senatec, Bosch, Cogen Europe as the coordinator of the project, but also responsible for communications and policy. DTU from academic perspective, Element Energy, the Technical University of Lucerne, Solid Power, Sunfire, and Wiesmann. And here is just another overview of the project. We have 9 different partners representing the OEMs, the manufacturers, the research community. The goal is to install over 2,800 fuel cell micro CHPs across Europe over a 6-year period ending in 2022. The units will be installed over 10 different countries. 4 countries were selected for further focus from a policy and market development perspective. And those countries include Belgium, Italy, the Netherlands, and the UK. I already mentioned the budget and the length, and of course, with Enfield, with PACE and other national schemes, the goal is to eventually, deploy over 10,000 fuel cell micro CHP units a year from 2020. Here's an overview of the different systems that you find in PACE. You will actually hear from 2 of the different types of technologies. You have the PEM units and the solid oxide fuel cells. So I'm not going to go into detail, but here are the different technologies, the different installed capacities and brands, let's say. Before April 2018, we had 108 PACE units installed. Since then, in October that same year, we've gone to 239, and through the many years of the project to date, May this year, we already have 1,783 units installed. And we expect to hit the 2,800 by the end of the year. Just a very quick overview in terms of the customers that purchase the fuel cell micro CHP. It's mainly residential. Looking at the types of homes, 75% of the customers live in a 2 to 4 person household. 95% of the respondents chose to purchase the fuel cell micro CHPs by themselves, and the majority, over 90% of the customers, actually own the building themselves. Again, continuing on the customer survey, the motivation to buy is mostly linked to CO2, reducing CO2, energy and cost saving opportunity as well. 63 replaced the existing heating system, 31% in addition to an existing heating system. In terms of building types, we find it's mainly residential, 94 or even higher, 95% are residential buildings. Although in some countries, you do see a further uptake, especially, for example, in Belgium, a lot of businesses, SMEs, are purchasing fuel cell micro CHPs, but not one, but 2, 3, 5, 10 in some cases, sort of taking a modular approach to meeting their heating and electrical needs. As I mentioned, building types, around 94 are residential, 81 of them are semi-detached. Most of the buildings are over 50 years old. In terms of willingness to pay for more for a fuel cell micro CHP than the incumbent technology, 72% of the respondents would actually pay more for a fuel cell micro CHP instead of incumbent technology. 50% would be willing to pay an additional 2,000 or more, assuming there are some operational savings around 30 years per month, and of course reduce carbon emissions around 20%. Just to conclude my presentation, just to sum up, let's say, it is a no-regret technology. It's future compatible. Today it runs on natural gas. Tomorrow it can run on other decarbonized gases, including hydrogen. It's providing the fastest carbon reduction pathway. It reduces CO2 emissions between 30 and 50% emission reductions today. It's fuel flexible and technology neutral. It's an enabler of the integrated energy system of the future. In the Ennefield project, so the project before PACE, one of the deliverables we were able to publish was looking at grid reinforcements, and with the technology of decentralized fuel cell micro CHP, we've calculated that we can actually save around 62 billion euros a year of unnecessary grid reinforcements. Finally, of course, we need a policy framework to create a level playing field on the pathway to decarbonization, accounting for all the benefits of fuel cell micro CHP, high efficiencies, primary energy savings, local clean air, and of course, CO2 reductions. I would like to just end my presentation with a video summing up the technology. All right, thank you for your attention. Thank you for the opportunity to present very briefly the PACE project. I'd like to end my presentation just to draw your attention to the PACE project, which you can find PACE website project at the bottom of the page. And there we have a joint declaration on stationary fuel cells with another EU-funded project called COMSAS, which is focusing on larger scale fuel cell micro CHP. So if you want more information about the declaration, if you'd like to sign up as an individual or as an organization, please go ahead and find more information on the website or contact Cogen Europe directly. Thank you for your attention.
Thank you, Hans. I've seen there are thousands of commercial units running in 10 countries, and I look forward to have micro-cogeneration also in Czech Republic, as it will be presented by Tomáš Voříšek later on. A pilot project is being prepared in our country, and we already have one question, which is in fact a key questions which we handle today and which we try to respond. And the question is how mature already the hydrogen cogeneration is at the moment, and what's the perspective in the future. So I think all speakers will think about the question and will try to answer it. So if you want to say something to it.
So I didn't quite catch the question.
How mature already the hydrogen cogeneration is at the moment, and what is the perspective in the future?
Oh, as I think Antonio mentioned earlier in his presentation, we already have around 18,000 fuel cell micro CHP units installed across Europe, and of course, with the PACE project, we're looking towards a goal of installing around 10,000 units per year, following the project, following the momentum from the project, and of course, with key EU drivers pushing energy and environmental legislation to support the uptake of carbon neutral technologies such as fuel cell micro CHP. So I think we'll hear from a lot of the speakers this morning, and also in the panel discussion where we can dive into this question in more detail. I hope that answered the question.
Yes. Okay, thank you. And there is one specific question which shall be taken care of by the technology, by the speakers from technology companies, which will follow now. And the question is how you look to the house's security, explosion, fire at the hydrogen individual use. So now I'd like to invite Alexander Dornsteiner from Fissmann to give the presentation about their fuel cells.
Yeah, thank you very much. Just one request: if you could share my slides, that would be great, because I'm in the train towards Berlin, and it's a bit easier if you would like to share the slides.
Okay,
this is fine.
Just a moment.
Yeah, that's fine. But starting with a short introduction, and then the background will be better in a few seconds. Sorry. I'm Alexander Dornsteiner, working as a product line owner at Fissmann Group since 2019, and was formerly employee of Weiland, one of our competitors, and also active in the field of, thank you very much, in the field of micro CHP fuel cells, but also other innovative technologies for the HVAC market. Yes, can you switch to a presentation mode, please? I don't know if this works.
Just a moment.
Yeah. Oh, great. Thank you very much. Now it's gone. I don't see the slides any longer. I just can't see the slides. They are. So I saw it for a few seconds, but then now it's black.
Sorry, just a moment.
Yeah, thank you.
Excuse me, gentlemen. I will start presenting the slides shortly. Just give me a few seconds, please. Máme tu jeho prezentaci?
Moment.
No, matej tam.
So just one proposal. If it really not works, we can also skip to the next presentation, and I take my notebook and try to share my slides afterwards. So this is also an alternative.
Yes, I think this is the best because I'm now not able to run your presentation.
Okay, so then we could skip. No problem. We proceed with the next presentation if this is possible.
Mm-hmm. Yeah, it's possible.
Okay. Okay, that's fine. Then I take my notebook with me and prepare for sharing the slides afterwards. Thank you.
So, okay. So, Alex, can you continue?
Yes, please, if you can give me the presentation mode, so I will share my screen.
So, you
Perfect. I think you can see, that's the wrong one. So I think you can see my screen yet?
Yes, I see.
Okay, so perfect. So thanks you very much. Good morning to all. Thank you for joining this this innovation part also in your country. My name is Alex Faber. I'm the head of product management in Solid Power since 2019, and I'm the part of this transition period because that's a completely new technology. I think in most of the European countries and also in the world. And we see also from Solid Power that this technology is very appreciated in the family household, like Hans has said before. So before I start my short presentation, allow me to present our company because I think the most of the participants don't know who is Solid Power. So I'm presenting who we are. So actually, Solid Power has 5 locations in different countries. So we have research center and development center in Switzerland and Australia, where the focus is more on the development of the cells, of the ceramic fuel cells in Yverdon, and principally is the whole control and electronics of our units, our CHP units, are developing in Melbourne, Australia. And from these 2 developing centers, principally, we develop our main product. Actually, it's a BG15. That's a CHP, that's a micro CHP that we then assemble in Heinsberg in Germany, in north of Germany near Düsseldorf. And in Mezzo Lombardo, where I sit in this moment, we actually has this prototype production plant of the G8X stack. This is a large stack where we can produce up to 6 kilowatt electrical power. But these are the minor, I say, locations of Solid Power. The bigger one that we can present today is for sure our industrial stack production plant in Trento. It's near the border to Austria. I think this is one of the biggest plants, or is the biggest plant in Europe, where we can produce up to 60 stacks per day. And this is, I think, this is one of the most important steps that also Hans said in his presentation, is the industrialization of the production of the stack to reduce the cost of this technology. What base is the focus for? So with this plant, what you can see this image here, we are able to reduce every year the production cost of our technology. Here we produce this 900,000 cells per year. So we transform from the powder, ceramic powder, in the complete stack 300 tons of this powder, and then assemble to the stack, test it, and ship it to Germany, where we assemble our final product. That's the BlueGen, this micro CHP product. I think Hans also make this short introduction. I think with our product, with this decentralized micro CHP, we can offer a really advantage for the end customer, for the end user at the end of the system, because we have many advantages of this. And with this system, we can in effect achieve very high efficiencies, because the major problem that we have with the centralized power generation power generation is that in this case we have the losses of the heat, what we can use with this micro CHP directly at the user. So the overall efficiency of the systems are very high, up to 90% of efficiency, because we can use local this heat and the electricity. Here we can see a short overview of our technology. So we are a producer and manufacturer of solid oxide fuel cells. So we are that's based on ceramic at the end, ceramic fuel cells. That is very complementary because we can use it in different ways. So at the moment in our standard micro CHP, we use it in gas to power and heat mode, as also known as fuel cell mode. So we start from gas, okay, and water. And with these two mediums, we transform the gas, the energy of the gas, in power and heat. This is the SOFC mode. Okay, this is the most common use at the moment. But you can see here we have three other major possibility to use these solid oxide fuel cells only for stationary use. One side is in electrolysis mode, so we can produce from power, so electricity, we can produce with high efficiency hydrogen, and with water or with vapor, we can use it also produce hydrogen with a higher efficiency. Then we have also power to gas or co-electrolysis production. But I think the most interesting on, I say it on the large scale, is the power-to-power solution. That is the major advantage of the SOFC technology, where we can use the same cell, like a reversible heat pump, to produce at one-step hydrogen. So I make an example. We have maybe a PV system or maybe a wind turbine installed. With this renewable energy, we are able to produce with this power cell, is the output of this wind turbine or PV system. We go to our fuel cells and use it in electrolysis mode and produce this hydrogen and a high efficiency. Then we store, maybe we can store this this hydrogen in a package, in a storage tank. And then when we need it, this hydrogen, maybe by night, where we don't have the light by the PV system, we can use this hydrogen in SOFC mode of the same cell, of the same fuel stack, and with the hydrogen produce power, so electricity at the end. And actually, this power-to-power solution we have with the SOFC or solid oxide fuel cells, we have the highest overall efficiency at the moment on the market. So it's really interesting also for large-scale solution, for cemetery production facilities and so on. This will be for sure the future. I say it's the future because at the moment there is no final product that we can offer to the market, but we are working on it to have, and I think in 2 or 3 years, a final product or finished product to offer to the market. But don't go to the future. Let's speak about today. What can we do today? Today we have our BG15. That's our main product that we can use with different fuels. So at the moment with methane, biomethane, LNG, and so on. And we produce with low emission, also Hans said, with no NOx and no SOx emission to the environment, electricity and heat with really high efficiency. And this is, from my point of view, also very important for the Czech Republic, where we can produce this electrical energy with a high efficiency, because the value of the electric kilowatt hour is higher than the thermal, okay? And this is, from the payback time, very important that we can reach this high efficiency. So also the payback times are better because of the high efficiency of the system. So here are the main advantages of the technology. So by producing locally our electricity, we can give our support to the, it's a complementary technology of the expanding of the electricity grid, and we can produce locally our electrical and thermal energy. And I think also looking forward in the future, actually our BlueGen is already capable to work up to 20% hydrogen mixture in the grid, in the methane grid. So also this technology today is prepared to work for the future, because one of the future scenario will be to add some hydrogen in the methane and to mix these two elements to have a better efficiency. Another advantage of the SFC, or in general of fuel cells, is that we have no vibration, and this is for sure in the residential hotels and so on a very important add-on or a USP, because we have no moving parts, and so no vibration, and it's a low noise level. So it's the perfect solution to install it inside a residential building. In addition, the system actually can work up to 8,700 hours. So we can produce 24 hours, 7 days a week, 365 days a year, independent electricity and heat. And this is the more important. And we can use the thermal energy when we need it. So the system is designed to work principally as an electrical generator, and use the thermal part only when we need it, maybe to produce the hot water for the shower and so on. Okay, here's a little product range or portfolio what we can use. So we have the VG15 that we can use principally for the residential and install it also cascade from 2 to 5, maybe for bigger multi-family houses or small commercial buildings. And then we will have from the Q1 of next year, the VG15, that's the bigger one. That's the solution for the commercial or industrial application, where we can cover up to hundreds of kilowatts with these units, where we are really competitive also from the price side with this product, because also thanks to our facility here in Italy. And this is, I think, also a big potential for the Czech Republic market, where we can place this unit for application where we have a high electricity demand. And then to finish, I will show you how this technology fits to the future, or maybe also today what we can do. Here we can see a power profile of a residential house of 4 persons on a day. So we can see that the blue one is the energy request from the building, and you can see it's a really bit moved, because we have here installed also a heat pump and an electric car. So we have installed a BG15. You can see the green line. It's produced 1.3 kilowatt constantly all the day, and in the night hours from 0 to 6 or 5 o'clock in the morning, we charge the car. So the most of the energy that we produce locally from the BlueGen, we use it to charge the car and to fit into the electrical electrical utilities of the buildings. And then we have all the starts of the heat pumps. So in addition, so you can see here the orange line is the battery status. Here we have combined the BG15 with the 4 kilowatt hour battery, and you can see that we have moments where we disload or discharge the battery because the heat pump and the cars is loading, and then moments where the loads of the buildings are low. So in these moments, like here between around 10 o'clock, we can charge this battery and use it for the peak moments, like maybe at 14 o'clock, where there's the dishwasher and so on that putting on, and the heat pump. And here we can see at the end of the day, we have an out-of-core self-consumption of 96%. Okay, 96% that I produce with the BG15, I'm using it with directly in my house. Okay, and also here the autarky, so from the grid is very high, up to 79 or 97, sorry, %. So it's extremely high. So you can see the combination of the blue gen and the really little battery, so around 4 kilowatt hours, we can cover completely energy demand of a building over. So a modern building with an electric car and a heat pump of 12 kilowatt. In addition, to finish, you can see here below that's the cost of the produced kilowatt hour, and this price you can see here. It's a price that I have calculated for the Czech Republic. So for the people that are listening, it's very interesting. I think cost for the produced kilowatt hour in the Czech Republic, and in the upper part you can see the payback time. You can reach also in Germany, but thanks space, it's also possible in the Czech Republic. So not maybe 7 years, but maybe 8 to 9 years, we are reaching maybe this payback time in the Czech Republic. So not only in the main market for us, this is a new technology, it's a good technology and a modern technology, but I think also this growing markets of the Czech Republic is very interesting for this technology. So I think that's from my side all. So if you have questions, here's the email you can write, and we will answer you as soon as possible. So I will give back to the organization, and I hope I was able to give you a short overview of our company of the technology.
Thank you, Alex. Thank you. And now we have some questions.
Yes.
First question is, what is the lifetime?
The lifetime, okay.
In 2012, we operated SOFC with natural gas, and lifetime was only two years. So if it is more today.
Yes, exactly. So the fuel cell has a degradation. Okay. Actually, we have a degradation of our units that is up to 7 years. So after 7 years, we have to change this stack. Okay, our servers go there and replace the whole fuel cell module. So after 7 years, so at the end, we include normally this stack replacement inside a service contract that the end customer pays, where you have the regular annual maintenance work and also the stack replacement. But actually the lifetime of the stack is 7 years, and of the units is up to 15 years, so 15 years.
Okay, thank you. Then there was a question about the house security, explosion, fire with hydrogen.
Yeah, okay, that's a very interesting question, because we actually, this is a certified unit, so it's not dangerous at the end, this unit. So we have all closed inside the system, and we have no hydrogen storage inside. So from the methane we transform what we need. Okay, we can modulate here, so there is no storage of hydrogen, and for leakage we have sensors and so on. So it's a complete secure units. We have over 2,500 units installed with over 50 million, so 50 million operating hours in Europe. So I think it's a proven technology. Yes, in CHP mode.
I see. Thank you. Next question. Today's MCHP run on natural gas question, but I understand you can burn also hydrogen, no? So
Exactly. So we have a dedicated unit that runs only with hydrogen, but at the moment we use methane, because it's the most simple medium that we can have everywhere in Europe to produce hydrogen inside the unit. So, but we can also run with LNG, in a few months or next years with LPG. So we are very flexible from the stack side of the fuel. Yes.
Okay. Next question: would you mind to introduce the balance of plant technology? Did it would significantly affect the stack durability?
Can you repeat, please?
Would you mind to introduce BOP technology? Did it would significantly affect the stack durability? I don't understand.
Yeah, that's a very technical question. Yes, we have it integrated. As at the moment in our BlueGen, we have this balance of plant integrated. So that's why we came up to 7 years exactly.
I see. So next question: was an environmental and/or techno-economic assessment done to highlight any potential advantages of the technology when compared to others? I think you presented, but
yeah, it's not, because this is it's not an alternative. It's a complementary technology and we work completely different, because in the most cases this technology will associate it to a PV system. Okay, but the working there is a big difference between PV and SOFC technology, because we can produce constantly this electricity, and we are working as a base load generator. Okay, so the perfect application for us is there where we have a constant base load consumption. A PV system works completely different, so this is difficult to compare these two technologies because they work completely different. Like compare a Porsche with a Fiat Panda. That's two completely different cars. You can drive from A to B, but how you drive is completely different. So it's not easy to compare these two technologies.
I see. Thank you. Next question: how much the EV charging, not using petrol to the same drive distance, is influencing the payback time of the showed home system?
Yeah, a little bit, yes, because you are able to consume all the energy that you produce. So that helps, okay, if you charge every day the car, yes, for sure. But in payback time, it's difficult to say. We have to make here an analysis in detail.
I see. So next question: could micro CHP accept LPG, ethanol, or methanol as fuel?
Yes, we work, as I said before, on LPG. So from Q1 next year, it should be possible to work with LPG.
And ethanol or methanol?
It's at the moment not, because it's a little bit dangerous with this technology. But actually, we have so much request for these fuels.
Okay, I see. Thank you. That's all for the moment. Okay. So now, may I ask Alexander to go on with his presentation?
Yes.
Shall I share for you, or will you be able to share?
No, I can now. Now it works, because I have previously worked with my iPhone, and that is not possible to share a selected screen. But I think now it should work.
Yeah, I see.
Just a second. So now you should see a red one. Okay. Thank you very much for your patience to the audience. And yeah, I will go present our activities in the polymer electrolyte membrane fuel cell business with more or less two topics. I would like to go a bit into detail. What is the challenge? Why we are working? Not only I think our company, but also our competitors, as we saw it just now by Solid Power. And second, what do we already? Also with an outlook on hydrogen. The challenge is, I think, obviously known. We all signed the Paris 2015 target to reduce significantly the CO2 emissions, and there's no doubt that we have to fulfill these commitments. But in the building sector, which is a very very fragile and diverse segment compared to other segments like industry or mobility, with a lot of different building types, with a lot of building different behaviors from the customers and owners of the buildings. We are absolutely sure that we cannot achieve that Paris climate reduction targets only by a direct use of renewable electricity. That means renewable power. So we need also, let's say, a base on renewable hydrogen, for example. I will come back to that later. Looking on an example, as we have it in Germany, we can see now here a backwards view in the last 3 decades. So coming from 1990s, we already have reduced in Germany in the building sector, it's just the building sector, not the mobility, not the industry, from 210 million tons per year down to 120 by 42%. Looking on the midterm target, which we have recently also strengthened according to the government in Germany in 2021, we now have to reduce in the building sector in Germany from 120 million tons in 2020 in the next, a bit more than 9 years to 67 tons. That means in a percentage point of view, we have to reduce more than we have it in the last 3 decades. And this considering the special effect of the reunification on 1989 and 1990 with the German eastern part of Germany. So this is absolutely not repeatable, this special effect, where at that time in the 90s, early 90s, a lot of old heating system for the eastern part of Germany were renovated. So that shows already in the next 10 years a significantly need to reduce CO2 emissions. What do we already, and also with the outlook for the already mentioned hydrogen activities, which is absolutely a big advantage for especially the technology of fuel cells. Looking back, what has happened in the last period of time, and I think Hans has already mentioned it in his statement this morning. So to be honest, we don't have planned that exactly in that way. You cannot plan it exactly in that way. So what we did is starting with a lot of R&D in Germany, but also in other countries. I think Solid Power is one of the first also, but also Hexis in that period of time. And then we established the German funding project, which is a practical field trial funded by the German government, Calux, which we installed the 500 units together with utilities at that time. Then building up on this national field trial with the both FGH joint undertaking projects, Enefield and PACE. And as you know, PACE are still running. And what is important, already mentioned today, that based on these demonstration projects from the German government or also from the European Commission, it's absolutely necessary, and this is, I think, also a precondition if fuel cells can really ramp up also in the Czech Republic, to build up national funding schemes and remove barriers, if existing, in the markets to be successful from an end customer point of view. The German activities have started really with a long period of time of let's say, convincing the policy that micro-CHP fuel cells can play an important role. This is a picture of the Hanover Fair in 2013, where the former Minister of Economic Affairs, Sigmar Gabriel, has visited the common booth on micro-CHP fuel cells of the German initiative fuel cell. And at that time, they have intensively started the work on the KfW program 433, which is really a very attractive one. I think Hans has already mentioned it. Looking on the, let's say, perception, like let's make it more or less a vision also and a target of the Germany. So this is not really a forecast because, you know, especially for innovative technologies, it's very hard to make forecasts. But the German initiative fuel cell, driven by the German Association for the Heating Industry, BDH, and Zukunft Gas, which is very important association for natural gas, but also for hydrogen in the meantime. We see a dramatically increase of fuel cells in the market. And this is just Germany, coming from a level of about 5,500 systems today, on the last year, 2020. Ramping up in a range of roughly 100,000 systems a year. This is challenging, quite obvious, but on the other hand, you can also see that beginning maybe from 2025, we see an increase also. This is also related to the fact that we are convinced that hydrogen, also in the heating market, will play a role. It has to play a role. I will come back to that in my next slides. And this gives definitely micro-CHP fuel cells a push in the market. And this is also, I think the statement is clear. We know about the challenges to really innovate with new technologies. And especially, I think, to be very honest, that the Europeans and also the Germans are not the very best in that segment. So we have a very good R&D in Germany with a lot of high potential universities, Fraunhofer institutes, Helmholtz institutes, and others. But to innovate really to a sustainable market on a long-term perspective, this is not really something which we have been successful in the past, and this needs to be improved. And I think, therefore, it's also important to make projects like the PACE project. This is the system of Viessmann. We have two systems. This is the fully integrated system with the Panasonic PEM fuel cell, which is our partner in that segment, including all the necessary components in the balance of plant, like the storages, the hot water storages, the peak heater, which is a module inside of our company, which we just take out of the stock and implement them in this system as well. The gateways, we have a digital interface there that also the customers can operate them with an app. It's clear, that's standard today, with flue gas system and everything. So this is the current main product which we have in the market, where we have sold in the meantime roughly 10,000 systems. The development, just a quick few topics here, started in 2014. So even before the implementation of this KfW program in Germany, with an expected running time of 60,000 hours with one stack. And then it followed the second and third generation in 2016 and 2018, with in addition 10,000 running hours for the stack each. So the moment we have the third generation, that's the PT2, we call internally with generation C, with 80,000 running hours expected. And also we introduced in 2019 a second product, which we call PA2. And this is where you have the possibility to use your own existing boiler in the basement, for example, and your storage, which you might have already. So this is an additional solution where we offer also the customers. And we will not stop this clear. We are currently planning the next generation, which will be introduced next year, with additional lifetime experience. So what I already said is that we have to fulfill the Paris Agreement. That's absolutely clear. And these left three pillars, energy efficiency, where fuel cells particularly play in, but also modernization of buildings. That means decreasing the energy demand by insulating, for example, but also the massive increase of renewable energies are the three main pillars. But we, as an industry, believe that green hydrogen have to play an important role in the future. As I said, the complete building sector cannot be decarbonized only by direct electric use, for example, by heat pumps. So we are massively increasing with heat pumps in Germany and other markets. That's absolutely fine. And they are a great technology, in particular in new builds. But we need complementary to that direct electrical use, also the green hydrogen, and this is really an advantage also for the fuel cells. Japan is the global pioneer here. That's I think already know. We have approximately 350,000 units in the market already there due to very consistent industry and research policy from the Japanese government, with leading to a steady cost reduction there. So in the meantime, I think fuel cells and our partner Panasonic alone has from that part more than 160,000 in the field, and this is really a mass market in Japan. Our co-CEO, Max Fissmann, is member of the National Hydrogen Council in Germany, fighting for the acceptance of hydrogen in the building sector. I think Hans and also I think also Antonio mentioned this morning that it's not yet clear that hydrogen is also being accepted from the European point of view. And also we have in Germany a strength discussion here. If hydrogen in the building sector play a role, we are convinced it has to, because otherwise we simply will not achieve our climate targets in the building segment. And by the way, hydrogen in the district grid will also enable the ramp up of other industries and hydrogen use, such as in the industry or in the mobile segment. So there is a lot of demand in the already existing grid, and we should use that from a cost point of view, from an economical point of view, and also from a point of view of the user acceptance of hydrogen in the different markets. So what is clear that we don't need a competition. We need a competition between the different technologies, but we don't need a hierarchy. So if some of the member states in Europe would exclude hydrogen in the building sector, this would dramatically impact also the use of hydrogen in other sectors. And in particular, as I said, the level of achievement of Paris 2050. Last slide, or the second last slide, the European Commission also with the redesign of the eco-design Lot 1 also working on that, considering a hydrogen readiness for the heating appliances, which will definitely be an advantage also for fuel cells. But, and this is my last slide, it's clear that we need a ramp up. So also in the Czech Republic, it would be interesting to have, let's say, demonstration trials and accelerated ramp up of fuel cells, which consists of manufacturers on the left side and also from association to Europe on the right side, which we work on, let's say, the question how to scale this interesting and high potential technology, which definitely not relatively high costs. Then you, leading to a really large market in the future. So that's my side. Thank you very much for the question. I'm looking forward to answer.
Thank you, Alexander. At the moment, we don't have any new questions. So we will, let's move to next presentation, which will be given by a researcher of Research Center Sibireš, Aleš Kejla, who will be talking about the Opcogen project. So, Aleš.
Pomůžete mi to tady nastavit? Hello, ladies and gentlemen. My name is Aleš Kejla. I am R&D at Research Center Czech. I have pleasure to present you our project dealing with possible future application of fuel cell micro-CHP in Czech Republic. I personally believe this project have potential to contribute the extension of this technology application in Czech Republic. The project name is optimization of micro-Cogeneration using fuel cell and its environmental and economical benefits. This project could happen thanks to program TRIO from Ministry of Industry and Trade, Czech Republic. And the main goal is to develop a software tool for economic evaluation of use micro-CHP based on fuel cell on Czech market. Part of the project is also analysis. As I told you, beside the software, the result of the project will be life cycle analysis of various options for supplying households by heat and electricity, and also the analysis regarding the current state of art in fuel cell micro-CHP, and also overview of legislative support of micro-CHP based on fuel cell in major markets. These two analyses will be available for Ministry Trade and Industry. Regarding to organization, project is coordinated by EGU Brno, by Mr. Peter Chambala. In case of any question, you can contact him. Also, the consortium consists of UGV, which dealing mainly with Lca Analysis, and Research Center Czech, which deal with the data collection for Lca and other analysis. Let me please show you how we consider the household model. Beside the define the boundaries and the size of the building, which is defined based of prediction of possible for a customer. We take into account various combination of options for household energy supply, which is of course fuel cell, micro-CHP, but also conventional gas boiler, photovoltaic panels, battery storage, central heat supply, and other local heat source. Of course, grid is necessary for every option in our calculations. Regarding to the software itself, here is some show about of the interface. The input for the software is Excel sheet with data about consumptions and consumption of the household we are going to solve. The current protocol works with 1 hour interval for each energy type, but it could be finer in the future. Software also take into account efficiency of all used devices, and also the energy lost in energy accumulation. Software will be also ready by possible add-ons for future government support measures, which may make the usage of fuel cell micro CHP more reliable. Let me show you the combination we consider for supplying household by electricity and heat. First two options are more or less conventional and available right now in Czech Republic, and the other three are with micro-Cogeneration based on fuel cells. We calculate the LCA on these 5 variations, and there is also possible to change or reconsider this combination based on the result of LCA analysis. If we would go more deeper into LCA analysis, as you can see on this picture, the LCA is taken is considered input are energy and materials for manufacturing individual devices, and also as output of LCA is considered recycling possibilities after finishing their lifetime, and waste processing of its weight. It's also considered the CO2 print of energy production of each type of devices. All the options will be compared and again reconsidered. Important part of the project are also analyses such as the current state of art of the technology. The important message in this analysis are saving potential on CO2 and energy in household sector for micro CHP, and also the readiness of technology is often inflected then, and the analysis is also deal with the longevity of key components, which is shown in several academic lists, academic studies, and customer satisfaction is usually also very good benchmark for readiness of the technology. overview of legislative support for micro-CHP in major markets are also very important, because it shows us how the support, how big role plays support from a government in a number of applications. In this place is very important to mention Japanese market, where the micro-CHP is known under the name Enifarm, which is also the project for supporting this technology in Japan. The solid government support here is reflected by a number of applications. It's about 400,000 applications now in Japan. And it's also given by a very good subsidy system. Another important market for us is Europe, where the installation reach a number about 10,000. The most important market is perhaps Germany, and Germany has also very good subsidy systems, but not only the direct subsidy helps to play Germany the major role across Europe. There is also the activities of local government. For example, the government in German land Hessen in year 2013 and 2015 they provide direct support for this technology. Including this analysis is also this description of all relevant project, as is Enifarm I mentioned before, previous German project Calux, predecessor of current PACE project Enefield, and also some local activities.
Aleš, last 2 minutes, okay.
Yes. This actually finish of my presentation. So thank you for your attention. If you have any question.
Thank you, Aleš. We have question for Fisman and maybe for Solid Power also. If they would really think that 24/7 operation of fuel cell is the best one in situation when sun is shining and power price could be very low from the grid, or even negative price. So for me the question is if the fuel cell can be operated interrupted mode.
Mm-hmm. Sorry, I didn't catch the question. Can you repeat it?
If it makes sense to operate 24/7 the fuel cell continuously in case there are negative prices when renewables are producing excess electricity. So if you can run the fuel cell in an interrupted mode, maybe.
It's also depend to other accessories for the household. Usually the micro CHP based on fuel cells has best results for non-stop working conditions. Also, it's important for increasing the longevity of the devices. But and if you have battery storage or any kind of storage, you can. It's probably vital to use it in a continuous mode.
Thank you, and Alexander. Are you connected?
Yes, I'm connected. Yeah.
So what is your opinion as a manufacturer?
Yeah, as long as you can or you have a heat demand, it makes sense to run the fuel cell. But I can confirm what the speaker before said. So this makes sense, yes, from a point of view if you have negative electricity prices on the stock market. But you need to have a little heat demand depending on the electrical efficiency of the system. But in principle, we can provide that. Yeah. But continuously running with let's say avoiding too much start-stops of the fuel cell is the general, especially on SFC fuel cells, but also on PEMs, we should limit the start-stop cycles of a fuel cell because then you have problems long-term durability of the fuel cell.
Okay, thank you. I see. Okay, thank you. Then we have a question again concerning the EV charging and division of investment costs for battery and fuel cell. So I recommend the person to contact Alex Fabrio directly for these details. Okay. Then we have next questions to Fisman. Can you share your plans with Hexis AG technology?
Yes, as you might know, we have decided last year to sell Hexis to H2E in India, but in particular to the reason that the role which we had previously with Hexis does not allow a ramp up of the technology. That means scale up in the market, and therefore we needed, let's say, a neutral technology provider, which H2E in India is. And we integrate the system into our systems. And now, by the way, the system and the technology is also available for others. Yeah. But we are still working on SFC because we think there is no single technology for all the requirements of the markets. So each technology has its advantages and disadvantages. And therefore, we are still working on SFC, which we are very, very interested. And currently, we also evaluating the technology of Hexis. But there's no, let's say, no market launch date visible at the moment. Yeah, this is still investigation and strategy set up.
Okay, thank you. So now let's move to last presentation in this first block, which will be again touching flexibility of fuel cell and how to use it for grid support. And the presentation will be given by researchers from Lucerne University, and Ben Bowler will present. Ben?
Good morning, everybody.
Can you share yourself? Yeah, okay, we see.
Yes, that was the wrong button. I apologize. Okay, can you see the slides and are they in full presenter mode? Not yet. Hold on. Yeah, can you see the slides? Is that clear?
Yes.
Yes.
Super. Yes. So good morning, everybody. Thank you very much for the opportunity to speak this morning. I am Ben Bowler. I'm a Senior Research Associate at the Estonian University of Applied Sciences and Arts. And today I'll be presenting with Andre Egli, who's a Research Associate, and we've been working on Work Package 4 within the PACE project. So what we want to present today is the results of some work that we've done recently looking at flexibility from the micro-CHP devices and how that flexibility can be offered to grid services markets. So we've been studying this opportunity across Europe. We've in particular been focused on Germany, the Czech Republic and Belgium. And so we'll focus in particular on the Czech Republic today in the presentation. So just to give you a very brief background on us and the scope of Work Package 4. So the Work Package is looking at income streams from participation of micro-CHP in grid service markets. We're looking at different revenue streams, and we're doing modeling to look at the potential revenue that could be secured by a micro-CHP device that was participating in a virtual power plant. So we recognize that this isn't possible in many markets yet, but we wanted to try and quantify the potential value that was available to the micro-CHP device as the ability of flexibility to participate in wholesale markets improves. As a research group, we focus on these sorts of projects. We're a competence center business engineering, and we work with a range of different actors in the energy sector, looking at impact analysis for different marketplaces, looking at modeling for different markets, looking at techno and economic analysis, and also looking at economic and market design. So yeah, just to give you the focus for today's presentation, so we considered different markets, and Andre will say a little bit more about this in a second, but we considered different markets for our analysis. We considered in particular secondary and tertiary control as TSO-led markets, and we also considered DSO, emerging DSO grid services markets, in particular focusing on congestion management and grid capacity management. So Andre will talk a little bit more about the results of the modeling for secondary and tertiary control, and then towards the end of the presentation I'll talk about the analysis that we did on the DSO benefits, in particular looking at the potential for infrastructure cost avoidance that could be attributed to distributed energy resources like micro-CHP. So I'll now hand over to Andre, and he'll talk a little bit more about both the opportunities for micro-CHP to participate in this market and the results of the modeling.
Thanks, Ben. Hello, everybody. So first, I would like to motivate our case. So why we need flexibility. And on the one hand, it can be said that with the uptake of new renewable energy sources such as wind and PV, which are by nature quite fluctuable, stochastic, we need more flexibility. At the same time, as those renewable energy sources take up speed, the conventional power plants such as gas and coal that today provide most of the flexibility are sometimes no longer profitable and are slowly being decommissioned. Micro-Cogeneration could fill in that gap as to provide some flexibility, which is due to the thermal inertia of a typical installation. Well, you see, you have a house, it has a hot water storage, and also the thermal inertia, just the mass of the house, that can also be exploited for providing flexibility. Thanks to the thermal storage, we can run the fuel cell whenever we think the electricity is most valuable, be that for self-consumption or be it for providing flexibility services. The heat demand is less important because of thanks to the thermal inertia, we can live a few hours without heat production, or we can run the peak load boiler. And in conclusion, it can be said that thanks to this thermal inertia, it's much cheaper to provide flexibility because thermal storage is cheaper than, for example, batteries that could be used otherwise. So on the next slide, we thought about how to approach it. So our question is, how much money can we get from providing flexibility? We've divided this into 2 steps. So the first step is just focusing on the self-consumption. So there we modeled typical domestic consumers. So we modeled a house in all the countries we considered, Czech Republic, Germany, and Belgium. We modeled it according to typical insulation standards of that house, according to the geologic conditions. And from that, we know the energy consumption patterns for electricity and also heat demand. Based on that self-consumption policy, we know when the fuel cell is running for self-consumption, when it's not running. And in a second step, we can then offer that flexibility to the transmission system operator, or also to the distribution system as a second part we'll then talk about. So that means when the fuel cell is not running for self-consumption policy, maybe because it's not lucrative enough, we can still offer to switch it on if there's a need from the system, if we get paid appropriately. So it has to be said that for both of these steps, for the Czech Republic, we collaborated closely with the Czech partner Nano Energies that provided us with data and market knowledge about the Czech market. So on the next slide, we want to give some brief results that we have for the Czech Republic. So here, this is the first step, the self-consumption policy, where we have simulated 4 different scenarios, as you can see in the plot. So we have 2 PEM scenarios, 2 SOFC scenarios. The left 2 scenarios, SFH, that's single family house. And on the right-hand side, we have 2 scenarios with a higher energy consumption, so higher self-consumption, that resembles a small to medium-size enterprise. The blue bar represents the costs for electricity and gas in case there is no micro-CHP present. So you buy all the electricity and all the gas to provide the heat with the gas burner, which is quite expensive. When you install a micro-combined heat and power unit, it will get cheaper because, well, I mean, gas consumption will go up slightly because the micro-CHP uses some additional gas, but the electricity consumption will go down a lot. And as you know, electricity is more expensive than gas. So in the end, there is a savings. The savings for the single family house scenarios are around 550 euros per year in that specific scenario under those assumptions that we have taken. And for the bigger consumer, small to medium size enterprise, it's around 1,000 euros per year. The figures for the Czech Republic are not as good as, for example, in Germany. On the one hand, that's due to the government subsidies that are not too great in the Czech Republic. So that's the status of past autumn when we did the simulations. And also the gas is quite expensive. It's around 5 cents per kilowatt hour, which is a bit more than Germany. And electricity is also quite cheap. So the business case by all those factors not as great as in Germany and Belgium. But still, it's a business case. Then in the next slide, so this was about self-consumption. The next slide is about the additional income that can be made by providing flexibility. We focused on 2 products, AFRR, that's automatic frequency restoration reserve, or secondary control reserve. That's activation time with you a few minutes. So when let's say a wind farm trips because there's too much wind, it needs to shut down, then this energy is missing in the system and the grid frequency, 50 Hertz, is slowly going down. If nothing happens, there will be a blackout. And so the transmission system operator activates the balancing reserves, and then first primary control, then secondary control. So within a few minutes, a cluster of micro-CHP units could be activated. And then the other service is the tertiary control. That's a little bit slower, so it's within like 15 minutes or so. We have again simulated the same 4 scenarios as before. And you see the additional income from offering those products additional to what we already have for self-consumption is around 170 to 300 euros per year. This is quite profitable and I guess a substantial side business case for micro-cogeneration. Also here we have collaborated with Nano Energies that were also partner in the DFlex project together with the Czech transmission system operator, and they have tested some of those aggregation of small-scale units with the fact that aggregation is now possible, legally possible since this January. So before it was not possible to aggregate such small kilowatt-size units, but now it is possible. So there will be some evolvement toward that direction, which is now legally possible. So with that, I would like to give back to Ben Bowler for the distribution services.
Thank you, Andre. So another part of the same task was to look at potential benefits to the distribution system operator. And in particular, we were looking at the potential benefits to avoid the investment or reinforcement of the distribution network. So as distributed energy resources, as renewable energy grows in the distribution network, and also as new loads like heat pumps and electric vehicles are brought onto the network, there's an increasing need for investment in reinforcement of the distribution network. And there's a potential for distributed energy resources like micro-CHP to play a part in reducing that investment. So we started off by, so we were investigating the potential benefit here, and we started off by looking at the conventional practices of the DSOs. So there was a survey done in 2019 of 815 German DSOs. Of course, this isn't a European study across Europe, but this represents really, there are a limited number of levers that a DSO has to be able to invest in their network, to develop their network in response to decarbonisation. So we see these as being broadly applicable to other markets in Europe, like the Czech Republic. So typically the list is there as you show the things that you'd expect to be most common, like increasing the cross-section of cables, increasing transformer capacity. These were cited by the DSOs in the study as typical approaches that they'd take. A more dynamic approach, peak shaving as an optimization measure, was also cited by some of the DSOs, but only a small proportion actually. So in 2019, you could see that most commonly DSOs would use conventional measures. However, there was an increasing number that was starting to consider new types of control or new types of new schemes to reduce the reliance on those typical approaches. So saying a little bit more about that peak shaving, what that involves is more of an active use of distributed energy resources. So the idea of flexibility, using the flexibility, is well established, and you're using demand response to reduce or defer grid investments. The typical approach that's being considered by the distribution system operators is a market-based procurement of flexibility, so using effectively the deferral or the avoidance of grid extensions to provide a value which can then be passed into a market. So there are a number of drivers for this change, this shift towards the use of distributed energy resources, things like new grid needs, maturing technologies, different actors having more ambition to work in more areas like aggregators, new market designs and new business models. So there's a growing awareness of the potential benefits of using distributed energy resources, and distribution system operators are starting to explore this through pilot projects, through studies, through case studies and so on. So with this in mind, this conventional approach and also this emerging approach using DER, we then investigated, using a literature review, the potential value of this to DSOs. So we conducted a literature review to look at the economic value of avoidance of grid extensions using distributed flexibility. there was actually very limited work on micro-CHPs themselves. So we studied more broadly on flexibility as a general topic, looking at other distributed energy resources. And again, these results aren't necessarily directly related to the Czech Republic, but they give an indication of the sorts of values. So what we found through the literature study was the flexibility benefit is somewhere in the region of 24 to 500 euros per kilowatt. And there was a cluster of studies which came in at around 200 to 500 euros per kilowatt. There was an outlier, that was the previous project in Enfield. The analysis there took into account some other aspects, things like the avoidance of centralized generation, which weren't considered in the other studies. So that shows the higher value, and we believe that this more narrow range is more consistent with the benefits that would be realized by the distribution system operator themselves. There are a number of conditions where reinforcement alternatives were attractive. There'll be a public report that's produced that goes into these in more detail, but there are certain conditions like existing infrastructure or certain characteristics of congestion and the capacity of existing equipment that made reinforcement alternatives more attractive. And those were also included in the study. So this brings me to my last slide, just conscious of time. In conclusion, the thermal storage, as Andre described, provided by the hot water tank and the building inertia, allow us to use flexibility in a way that's profitable. Although we found that the self-consumption policies in the Czech Republic made the business case for self-consumption less favorable than in Germany or Belgium, actually the revenue potential for Czech balancing markets shows being more attractive than in those countries. And so there's a potential benefit to consider in the Czech Republic for using micro-CHP in this way. We also found that demand-side flexibility has a benefit in avoiding distribution grid investment. However, it should be said that the local grid services at the distribution level are still very much emerging, and so the data for really reliable modelling is still quite scarce. So this is very much based on case studies, on modelling and literature that's been produced so far. As part of our next task, just want to make you aware of this. We're actually looking at the steps to realising the benefits of fuel cell micro-CHP in providing these services as part of a virtual power plant. So Andre mentioned the DFlex project. The next part of our work over the next couple of months will be to analyse the roadmap that will take place, that will allow the fuel cell micro-CHP to actually participate in these virtual power plants. So that will give us a clear idea about what's required, and that will allow discussions with regulators and with manufacturers to actually realise the potential that we've described in this presentation. Thank you very much for your attention. Now available to answer questions.
Thank you, Ben and Andre. Thank you. We don't have any questions now, so I'd like to thank to all speakers for the interesting presentations. And because we are in delay, so we will move immediately to the panel debate, which will be started with the presentation of Peter Merwart, who is plenipotentiary of Ministry of Industry for Hydrogen Technologies.
Good morning, ladies and gentlemen. So let me introduce myself. At the Ministry of Industry and Trade, I'm responsible for all the stuff which is somehow related with hydrogen. And definitely part of our hydrogen strategy on which we are working now is also cogeneration and micro-cogeneration. So therefore, this fits well into our future strategy. Maybe some about the background of Czech hydrogen strategy. We are just finalizing it. Now it's in the review by all other ministries, and if everything goes well, we can expect that it will be approved by our government in beginning of mid of July. So afterward, it will become the official document. But today, I would like to go with you very briefly and to show what's inside of the strategy, why we created that, and what could be impact of the strategy to some technologies and to the future development. But very first question which we asked ourselves before we started to write down the strategy, we ask us why do we need the strategy. And at the end, we had about 2 strategy goals which must be addressed by the strategy. The first one is definitely the reduction of emission of greenhouse gases, which relates with European Green Deal. And definitely, as you can see from that picture, the Czech Republic is not the best country in emission, which are put into the air. Definitely, we are not as bad as our neighbors on the north, but definitely there is a lot of countries which are in much better shape. And hydrogen is regarded as one of the options how we can improve the emissions. And it has been already mentioned several times, hydrogen is an important tool how to reach the goals of European Green Deal. And the second strategic goal is about the stimulation of economic growth, because Czech Republic is the second most industrialized country in the European Union. And it means that we have a lot of industries, but a lot of these industries are highly dependent on fossil fuels. So it means that they are producing a lot of carbon dioxide. And with all the regulations which are around us, these industries must go down. You know, there is no doubt that these industries needs to be transformed. And what's very important is, and it's shown in the graph on the right side, that we need to do the transformation to the low carbon technologies. We need to start the new industries which will be replacing the old ones, and we need to make sure that that start of new industries is quick enough that at the end the overall performance of our economy is not going down, but it's increasing, and there are only some, let's say, periodical fluctuations. So how to reach these 2 goals? To be able to fulfill these 2 strategy goals, we divided our strategy into 4 pillars. It's a production of the hydrogen, usage of the hydrogen, transport and storage of the hydrogen. And due to the fact that all these topics are very new ones and all of them will need a lot of new technologies, we also put into the middle the 4th pillar, which is a technology which is supporting all these 3 pillars. And what's very important to say at the very beginning, that we believe that the only one way how to achieve the efficient implementation of the hydrogen into the economy is very close interconnection between all these 4 pillars and the alignment between these 4 pillars. So at the very beginning, we need to make sure that the production and the usage of hydrogen is in the equilibrium. It means that we are not making any production plants which are not able to sell the hydrogen to some consumers, and on the other side that we do not have a consumers which do not have the hydrogen which can be used. If I take some example, we need to make sure that if there are some filling stations for hydrogen, these filling stations have cars which are using that hydrogen, and that we have some suitable production of that hydrogen for these cars and the filling stations. So let's have a look how these particular pillars looks like. If we start with hydrogen production, definitely the most important topic for us is the production of hydrogen from renewables. But there is small but. Czech Republic is a very nice place for living, but unfortunately we are in the middle of Europe. So it means that we do not have so much sunshine as the countries in South Europe, like South Italy or Greece. The problem is that we are not able to cover all our future consumption of the hydrogen from renewables only. So probably in the future, we will be forced to import the hydrogen from other countries, and we will talk about that later. But
Peter, sorry to interrupt you. We still see the first page of your presentation. Maybe you have to share other window.
Okay, so I will start. So actually, in that case, I will try to do it slightly different. So sorry that you lost the pictures. So let's make another attempt. And if I share it in this mode, you can see the movement of slides.
Yes. Now
okay,
it's now okay.
So actually, I will. And is it big enough?
Yes, it is.
Okay, so unfortunately you saw only these, let's say, an empty slide. So afterward I had these two pictures, that one picture with the strategic goals and with that paradigm change. And these are that 4 pillars: production, usage, technology, and transport. And now let's go to the particular pillars. So I said that unfortunately we do not have so many renewables to cover the whole need of the future hydrogen. So we need to check also some other options. And we did the evaluation of many of technologies. And actually, this was done in the whole strategy, and I will come to that later, that we are evaluating and comparing different technologies. And out of that comparison, there are about 3 topics with which we should start. The one is production of hydrogen using the energy from nuclear plants. The second one is usage of natural gas, but definitely we need to do something with carbon dioxide. And unfortunately, there is not so many places where we can store it, so we need to find some usage for that, and we need to, let's say, find some way how to utilize that CO2. And the third option we would like to check is pyrolysis of organic waste. At the very beginning, I must say that all these options looks great. There's a lot of people who put a lot of stakes into them, but today they are not available. Today there are still not technologies which can be used immediately. So it means that what we can use just now are the renewables, and we need to spend some time to develop these technologies. If we go to second pillar, to usage of hydrogen, we are trying to find such a way where the usage of hydrogen is the most effective one. And we found there are something like price break-even points, because with hydrogen we are trying to replace some fossil fuels. And if we compare that fossil fuels, we have diesel in mobility. We can have gray hydrogen to be replaced by the renewable or low carbon hydrogen. And third, fossil fuel which we can replace is natural gas. If we do some calculations to be on price parity from the operational point of view, we have that break-even point for diesel at about €4 per kilogram. With gray hydrogen is about 2.7 euro per kilogram. But unfortunately, to replace natural gas by hydrogen, we need to go to the price of 1 or 1.5 euro per kilogram. And unfortunately, we are not very close to that price, because still hydrogen today is about 7, 8, 9 euros per kilogram. But we believe that with mass production, the price will go down. But nevertheless, from this point of view, it seems that the mobility is something where we should start, and with mobility, with replacement of hydrogen by, with replacement of diesel by hydrogen, we can get probably the best cost ratio. But again, there are some buts. The first problem is that we are comparing not only operational cost, the OPEX, but we need to compare also investment, the CAPEX. And if we take both ends of the scale, it means replacement of natural gas and the mobility, we are getting a little bit different picture. Because if we would like to have some trucks with hydrogen, these trucks are about 2 times more expensive than the normal trucks for diesel. On the other hand, if we are replacing some burners for natural gas, the replacement of the burner for natural gas by burner for hydrogen is relatively very cheap. So we need to take into account all these two views, the OPEX and CAPEX. The third pillar, as I said, is transport and storage. At the very beginning, we will try to make sure that the place where the hydrogen is made and the place where the hydrogen is used are very close, preferably at one side. Which can dramatically reduce the cost of the transport, because the transport is expensive. We have a lot of means how we can transport the hydrogen as a gas, as a liquid, or it can be somehow bound into organic stuff like LOHC or in the form of ammonia. But unfortunately, all these ways of the transport are relatively expensive. It adds about 2 euros per kilogram on the transport. The most effective way how to transport hydrogen is by pipes, by hydrogen pipelines, because in that case the cost is about 20 cents per kilogram per 1,000 kilometers. But unfortunately, these good price we will get only in the case when the full pipeline is filled with hydrogen, and it means that we need to have a big source at the very beginning of the pipe, and we need to have also a big consumer at the very end of the pipeline, which is not the case for the very beginning. So we need to use at the very beginning some other options for the transporting hydrogen. And the last pillar are the technologies which are connected to all three previous pillars. We made something like a map of the technologies where we are checking what kind of technologies we are producing here in the Czech Republic, and our plan is definitely to put a little bit more of Czech flags into that, and maybe there could be some, let's say, flags about the fuels, about the fuel cells, not only for cars and buses and the trucks, but also for households. And this could be, let's say, the good point for cooperation. As I said, for each of that 4 pillars, we did some evaluation of the technologies which are related to that, and the technology evaluation was based on so-called bubble charts, where the size of the bubble was, let's say, some expectation how much of the hydrogen can be produced or used by the technology, or what's possible market share for the technology. And on axis, we had the technological readiness level, where we used the technological readiness level by IEA, and on the vertical line, we had something like an economical effectiveness of that technology. So from our point of view, the best technologies and the technologies which should be promoted and with which we should start are that ones in the top right corner. But unfortunately, I use that graph, which is good that we have something here. But I must admit that with a lot of other technologies, we have the technologies which are more here in that bottom left corner. But definitely, there is we need to put some effort, and we need to try to move these technologies from the bottom left to top right. Some small remarks about the timelines. As I said, we see the mobility as area where we can start very early due to that operational costs. On the other hand, the usage of hydrogen in industries and in households should be a little bit later. It should be in the moment when the production of hydrogen will be established and when it will work. So this is really the last slide. It's about the micro-cogeneration. I said that the cogeneration is a part of the strategy, and definitely we see a lot of advantages in that. And it has been already mentioned several times that this is a good way how to move, how to turn gas, and it could be natural gas or hydrogen, into electricity and heat. The biggest advantage of this approach is much higher efficiency than anything else. That this is the best way how to squeeze out the energy out of natural gas or hydrogen. The problem is that we need that in any case we are getting the both kinds of energy. It means the heat and electricity. That but on the other hand, it's similar also with some other ways, and this one is the most effective one. So it means that we will get some reduction of CO2, and in case we are using the hydrogen, there are definitely no emissions, or actually the emissions are only related to the could be related to the production of the hydrogen. I must stress that, and I do not know if it has been mentioned already today, that one of the biggest advantages of that technology is that it's very quiet. So it can be used in sites where you cannot have the engines or something which creates the noise. And we also see a big option to use that technology with a biomethane, which is produced on some sites. So it means to use the biomethane which is produced by somebody, and after the people who are producing that biomethane can get the heat and electricity on their own of that. It has been already mentioned in the business case that the energy in the natural gas is cheaper than energy in electricity, and most of the business cases for calculation of these micro-cogeneration units are based on the difference in these prices. The only one disadvantage of that technology is that it's expensive today. But nevertheless, and it has been mentioned several times today, that with a mass production, the price should go down, and there are, let's say, good indications of steady reduction cost of these units. And again, what has been mentioned here, in Japan, this technology works. There is more than 300,000 users, and it's using for a long time. So there is, let's say, good track of positive experience with that. So the very last slide, which I'd like to show, is at the end, I like to use that story about this Mr. Stephenson, and I believe that this steam engine is fine also for hydrogen, because at the end we are getting only the steam out of the fuel cells. But today we are in similar stage as was United Kingdom before Stephenson. There were a lot of technologies. We had a steam engine, but it was not effective. It worked. With hydrogen, we have also a lot of technologies. All these technologies are working, but we need to put them somehow together to create some combination of several technological improvements, as it was done by Mr. Stephenson with his locomotive. And only, let's say, the fine-tuning of these technologies can bring very effective usage of given technology. Similar case was, maybe if we are not going to so deep history, it's iPhone, which also combined a couple of technologies which were available. Or another is from the airplane history, Douglas DC-3, which again put technologies which were on the market, but they put them together by such a way that they create a revolution in passenger transport. And I believe that the discussion which will follow with our panelists could bring some shade of light into the future of that micro-Cogeneration, and can, let's say, put another piece of puzzle into that whole mosaic of the hydrogen technologies, which will bring us to the targets which are defined by European Green Deal. So thanks a lot for your attention, and now we can go to the panel discussion.
Thank you, Peter. Peter, in the program we announced a panel debate, but we realized that the panel debate about the status and perspective of micro-cogeneration and fuel cells, but we realized that the topic deserves also presentations. So it was and it will be the case also for next speaker, Tomáš Voříšek, who will be presented a project of pilot installations in Czechia, which is in preparation. But before we start, there is a question coming for André. If you are still with us, André.
Yes, I am.
Yes. So the question is, why is the income from supplying to the grid for 3FH lower than for SFH?
Sure. So basically to repeat, it's lower for the higher. So the higher the energy consumption. So for the SME scenarios, it's higher. The lower the income from the balancing market. That is correct, and that's due to. So when you think the self-consumption is higher, which means it's less profitable to switch off the fuel cell because there is too much electricity in the system. So when you switch it off, you have to buy the electricity from the grid instead. So you get a little bit of revenue from the transition system for switching it off, but you have to buy the electricity, and that's expensive. So that's why we have also taken this into account in the balancing services. So it's more of a self-consumption thing, but we said additional revenue compared to self-consumption, so we put it there, and it lowers the numbers a little bit.
Okay. Okay, thank you. So now, Tomáš, go ahead with your presentation.
Okay. So let me briefly introduce you the project, which is actually in the preparatory phase. Milan, are you able to see my screen?
Yes, we are able to see.
Great, thanks a lot. The title of the project is to verify the viability of the introduction of energy services based on micro-CHP in Czechia. It's a project which has been initiated a consortium of a total of 3 organizations, and we would like to test that service because of its, let's say, complexity of micro-CHP products seems to be quite, and investment costs are definitely high, and this is something which has been found as a quite big barrier for the market introduction. The project consortium is composed of Innogy Energo. It's actually energy utility company which operates in Czechia tens of CHP units just in the form of energy services. Unfortunately, fortunately, for the time being, they are having, let's say, much larger capacities than micro CHP category. Beside Innogy Energo, the technical partner is my company, 7 Energy. We are a small-scale entity working in energy sector for nearly 30 years. We do focus in our work on so-called energy performance contracting. We are facilitators of these type of contracts, and that was the reason we have decided to join the team and try to think up how such a, let's say, contracting could look like for the residential customers. The third partner is the Czech Technical University, UCEEP. It's academic institutions, and we have decided to invite them for the project in order to have the possibility to test the technical parameters of micro-CHP units in laboratory, and to have an independent verification of the data or parameters which are, let's say, specified by the manufacturers. The project shall start during this year under condition it will be approved by the for co-financing by the program OPIC. It's a Czech EU structure funding program which has as a one sub program so-called Aplikace, which means that such type of program supports applied research and demonstration activities. The important thing is that why we have decided to enter this market, that until now micro CHP units actually more or less doesn't exist in Czechia. There are only, I think, two installations at the research and academic institutions, and there is no below the electrical output 10 kilowatts so far. I think there is no even any installation. So we are lagging behind, and we would like to change the situation and have hand-on experience with designing an operation of such small-scale units. The important thing is that the let's say micro CHP market shall be growing during the next decade. So-called National Action Plan for Climate and Energy put forward the forecast that as much as 30 megawatts of electrical output, the total installed capacity, shall be realized between 2021 to 2030, which means that it could theoretically result in the tens of thousands of installations of small-scale CHP units. Of course, the precondition is that it will be economic, and for the investors, such an investment will be cost-effective. The project work plan is composed of 3 phases. The first one more or less already started. We have started with conducting market analysis, what is offered on the market. We already heard today from my predecessors that there are more than 20 products on the market in Europe which could be purchased and which could be installed. We would like to, within the project, procure and install a total of 9 micro-CHP units, and 3 of them would be installed at the laboratory of Czech Technical University in Buštěhrad, and the remaining ones would find its use or installation in various, both residential as well as administrative facilities. So we have already started to identify prospective or suitable locations. After phase number 1, we will start with the demonstration and testing. It will take for, let's say, 1 year, starting from the beginning of next year until the end. And afterwards, it will follow the last phase, in which we would like to let's say, develop guidelines how to design and operate these plants, and of course whether there are good prospects for offering them as an energy service or energy contracting service in the future. Regarding the technologies we would like to test, so there has been made a decision that we would like to have 6 micro-CHP units based on fuel cell. Probably 3 of them will be solid oxide fuel cell type, and 3 will have a proton exchange membrane. The 3 units would then be based on an internal combustion engine, and all of them will have the electric output less than 10 kilowatts. I think we would like to or select the installations with the maximum electrical output 5 kilowatt. What we already know, we may say that we have already made something like a preliminary list of prospective models. So I can share with you the list, which actually is being, let's say, collected in the framework of so-called BAFA program in Germany. All these technologies or models can be procured for Czechia, and they can be installed, let's say, as planned. So I do not have to go into detail. What we already know, the biggest barrier to the development or the market, let's say, viability of micro-CHP units will be definitely investment costs. So for the time being, what we have received as a preliminary price offers, the prices are quite high. I would say as much as 10 times more than the large-scale CHP gas-driven units. So this is something which will hopefully will be changed during next years. So the market is definitely for small-scale units in terms of investment cost really big challenge. Regarding internal combustion engine based models, they are much more affordable. And if we calculate the levelized cost of electricity, we arrive at figures which are in hundreds of euros per megawatt hour for both technologies. If we compare these costs analyzed into production of electricity to the residential prices of electricity in Czechia, we can see that, let's say, the production price of electricity from small-scale micro-CHP units is several times higher. Our intention would be to verify these figures, to check whether, let's say, the number of operational hours and of course, costs for maintenance will be as expected. And we would like to also contribute to the discussion whether and how shall these small-scale micro-CHP units be in Czechia supported on a more intensive level than is currently existing for the larger units. So we will see. I do hope that we will arrive at positive conclusions, and we will help to accelerate or introduce micro-CHP technology in Czechia within 2 years' time. Thank you for your attention, and I'm available for any further questions.
Thank you, Thomas. And now we have last member of our panel debate, which is Aleš Doucek, chairman of the Czech Hydrogen Technology Platform. Aleš, please.
Good morning, ladies and gentlemen. I hope you can hear me. Okay.
Yes.
Perfect. Firstly, I would like to introduce myself. My name is Aleš Doucek, and I am representing Czech Hydrogen Technology Platform, which is an association of companies, research institutes, and universities active on hydrogen technologies in the Czech Republic. I would like to express my big thanks to organizers of today's very interesting workshop, and I think for a long time it is one of the most interesting event in the field of utilization of hydrogen technologies in households and for micro-CHP. At least in Central Europe. So thank you, Milan, for really good work you did. Also, I'm very glad that, as I said, Czech Hydrogen Technology Platform, it's really growing in last years. At the moment, the platform has more than 30 members, 30 partners. And I think it's also a good demonstration that hydrogen technologies in various segments are being more and more interesting for commercial companies. And really, we are at the start of something big, which is implementation of hydrogen technologies, fuel cells, in mobility segment and also heat and electricity segment. I'm also very happy, and I would like to thank Mr. Mervart and Ministry of Trade and Industry that hydrogen will be included to national strategic documents, and I hope that very soon national hydrogen strategy will be approved by Czech government, and we will have a very clear way or clear timetable how to go further with hydrogen. So thank you very much for very interesting workshop, very interesting presentation, and I'm open to discuss any of topics. Thank you.
Thank you, Aleš. So we are running out of time, but we have still 15 minutes left. There are no new questions from the participants. So if I may ask anybody of you who would like to comment on the presentation and the topics discussed. In the meantime, I'd like to mention that thanks, I'm the organizers were namely Cogen Europe, represented by Thomas van Howard, and Martin Šilhan from Research Center Řeš. So thanks to them for organizing this webinar today. And as we have seen, fuel cells are obviously a very promising technology, which of course deserves the support which has been given and is being given to other technologies in the energy field. So we'll see how it goes further. So Hans, if there are no other comments, so I think we can close the webinar, or if you want to say something.
Thank you, Milan. I'd just like to thank Milan and Cogen Czech and the Rej for helping to put together this workshop. This is the first of this type of workshop that we have organized under the banner of PACE. Anywhere in Central Eastern Europe, we see a lot of prospects for fuel cell micro CHP in the Czech Republic. I think the market conditions are ripe for the technology. The technology is still going through a development process in the sense, in terms of, well, increasing the volumes that are needed to bring down the costs, but it has already been demonstrated that it is a cost-effective and environmentally sound technology. You see that especially in countries like in Germany, in Belgium, in Italy, as well as in the UK, France, and other countries. And we see the Czech Republic obviously as a country ready for further deployment of the technology. I think it certainly is in line with EU environment and energy policies today, and of course soon we will be discussing in Brussels the Fit for 55 legislative package, looking at the review of the Energy Efficiency Directive, the Renewable Energy Directive, energy taxation. There are over 45 different pieces of legislation that are coming out over the summer, and certainly with the right policies in place that will only further incentivize the use of this technology. I myself, as a user, I'm quite pleased. I've had a fuel cell micro CHP for 2 years now, and I produce around 13,000 kilowatt hours per year. That satisfies my electrical needs. I have a plug-in hybrid, a 25 kilowatt battery that allows me to drive to Brussels and back to my home, fully electric. So I'm very pleased about that as a consumer. The market conditions in Belgium, the spark spread, allow a reasonable payback time of 7 to 8 years, with some support from the regional authorities to support the further uptake of the technology. So it's certainly a technology of today, and certainly future-proof in the sense that it has a long prospect in terms of upcoming and future legislation in terms of energy and environment. So I'd like to maybe end with that, and again thank the organizers and Milan in particular for being the moderator, the master of ceremonies this morning. It was a lot of very interesting presentations. I hope we answered a lot of questions as well that may be out there, and of course we're available to you as the PACE Consortium to answer any further questions you may have. May they be technical, may they be financial, may they policy oriented. We're very much looking forward to further interaction with the community in the Czech Republic. So thank you again, and congratulations yesterday for your win in the football match.
Okay, thank you, and goodbye to all of you, and have a good rest of the day. Goodbye.
Thank you, Milan. Thank you, everyone. Bye-bye.
Bye-bye.
Thank you very much.